I'm going to be talking about the incenter right now. So the incenter, as a nutshell summary, is the intersection point of the three angle bisectors in a triangle, and where those three angle bisectors meet is going to be the incenter, which is the point at which I can center the largest possible circle that would fit inside the triangle fully. So first of all, what is my angle bisector? If I have an angle bisector over here, essentially what I have is I've created line AD or segment AD so that angle BAD is going to be the same measure as angle DAC. So I have split my angle in half. And I can do the exact same thing with ACB and ABC. So now I have three segments which are able to bisect all of my angles. If we look over here, ACF is going to be the same measure as FCB, and ABE is going to be the same measure as EBC. Now, what is special about the incenter? I'm going to label the incenter as my point X. And now if we go back, let's see, we are up to letter G. Let's actually start looking at what's special about it. The shortest distance between any point and a straight line is going to be the line that goes through the point but is perpendicular to my segment. So if I want to find the shortest distance between point X and segment AC, what I want to do is I want to find the line that is perpendicular to my line AC going through point X. So that's what I've just created. And if we look over here, these two lines are intersecting at 90 degrees. So the shortest distance between AC and X, it goes between P and X. I'm going to label this as G. And if we just do that two more times, I'm erecting a perpendicular that is between BC and X, and I'm erecting a perpendicular between AB and X. So here, all of my blue lines are going to be the same distance. So that's going to be the magic of the incenter. The incenter is a line that is equidistant to all of the sides of a triangle. So a circumcenter, if you saw in our last video, is a line that is equidistant to all of the corners, all of the vertices of my triangle. This is equidistant to all of the lines. Remember, these are all meeting at 90 degrees angles because that's how we measure distance between a point and a segment. And if I label these, let's call this one H and let's call this one I. Now, this is where we inscribe the circle. If I draw a circle and I have it touch my perpendicular segments, then that's going to be tangent to all of my edges of my triangle. So let's actually look at that. So I have my triangle in black, my angle bisectors are in pink, and my perpendicular segments and my inscribed circle are all going to be in blue. If I start moving this around, notice how everything is able to change. So no matter what, the incenter is always going to be on the inside of my triangle, unlike an orthocenter or a circumcenter, which can be on the outside of a triangle. And what else do we see? We also can notice that wherever I drag this, my circle is always going to be exactly inside of my triangle, and it is the largest circle that I can fit inside my triangle, no bigger, no smaller. So in summary, we have an incenter, point X, which is the center of the largest circle that can fit inside of a triangle, and the distance between that center to all of my edges, so xi, xh, and xg, all of those distances are going to be the same. So an incenter is the intersection of three angle bisectors, which create the center for the inscribed circle.